So good morning, and this is a talk through of the MATLAB code that runs the Rise, and there are some things that you have to be aware of when you run it. So we'll start with very simple programs and build up as we go along. So if you follow the code, run each program, then you'll start to make sense of what's going on. Now, the first thing, there are basic commands which you can run. So one of them is this one here. Now, this symbol here, R, you can choose, but R is quite a simple symbol. You could call it Bill or Ben or anything you liked, but you've got to put some symbol here, equal rise, open, close brackets, semicolon. This tells MATLAB that you're using the drone to send the commands to. As I say, you can use any letter you like here or any word. You can't use two words with a space in between. Now, if things are going, you can use abort then with R, and that will, whatever it's doing at the current time, it'll stop and land. You can use takeoff R, which forces the drone to take off and hover at about 0.6 of a meter off the ground, and land R will land it. And now it's when it does this essentially opens up communication with the drone, and if you don't close the communication, it remains open. So when you try and communicate it with it again, it won't communicate because it's already communicating. So once you've finished the program, you also need to say close R to stop talking to it. So as next time you have another go, it's ready to talk. So there's some key elements here now. Now, if it goes wrong, you have to type in land R at the MATLAB command prompt window. So that's one thing to bear in mind, but there's a trick you can use to avoid this. So if we're looking at some MATLAB code, now you could just have R equals rise, take off R, and then I've got a move up here. So it moves up a distance of 1 meter, and we'll leave these bits for the moment. And then it lands. So you could just have that code on its own, nothing else, not without these bits at the start and end. Now, the problem will be is if you say made a mistake here and didn't put a comma in there, so it's a mistake in this line. When the code ran, program would crash and it would stay in takeoff mode, and then you'd have to go down then to command window and type in land R. If you didn't do that, it wouldn't land, and then what would happen was just keep on hovering until the battery ran out. If you try and grab hold of it, it doesn't like it because it's trying to maintain where it is, and so it'll fight against you by increasing the power on motors, so it makes it worse getting hold of it. You can try it, it's quite fun, but you can see there's a control system working there which does what it wants to do and not what you want to do. So bear that in mind. You'd have to press in enter then, and then that command. At the moment it won't work because I've not defined R. So the next thing you can do is add this bit of code in. Try. Now clear all is a handy command. This one essentially, any from the previous times that you've been running your drone, it stops it from using up too much memory because you've used up memory using some pictures or something like that. But anyway, so try and clear all is a handy command at the start. Then you have your R equals rise, take off, move up, land. But then it's got this extra bit of code down here now. Now, with the try, if this code crashes, it immediately goes here. So this is an advantage now. So with this try in here, if this code is wrong, it goes into this part here and it lands the drone, clears the memory, and this is just a MATLAB command to stop using this exception next time. So this is a better, safer piece of code for you now. So you always need this try and this bit of code down here in your program, because that will give you the advantage then. If you do, and you will definitely, I've done it hundreds of times, if you make a small mistake in this line, then the drone will still land straight away and you save you messing about with the drone. So that's our first little thing to bear in mind. And we can then move on to the next thing. So the next thing is we've got different ways of moving the drone. So we've got move, move forwards, with object drone is the whatever you've called it. So if you called the drone R, then this would be R in here. If you'd called it Ben, that would be Ben. Depends what you to call it. You can also have it move forward. If you give it a standard command, move forward, it has a default number in here, like a meter or something, and it'll move forward a meter. But you can do a little bit more than that. You can set the some different variables here. You can set like what type of variable you want to move forward to. You can move forward on a distance, or you could move forward a certain distance at a certain speed as well, or over a certain length of time. So you've got different ways of moving forward, and in order to do that you have sort of different variables you can put in here. And I'll try and explain those next. One of the other things that can be going on with these commands is that you can either have the command to run, and whilst that command is running you can do nothing at all, so it just runs and then moves on to the next one, or while that command is running you can be watching what the drone's doing. So you could be like collecting up data of say height or forwards X or Y data. You could be collecting up information and putting that into somewhere where you can later on use it to plot. So that's some of the features that you've got with these things here. Sounds complicated, but it isn't that complicated really. So let's have a look at some examples of this. So we've got move forward R, then we've stipulated its distance that we're moving. So this is like the variable. We're going to move forward a distance. It could have been moved forward speed. And then this is the distance that we're traveling, 2 meters. Now, wait until done is one of the features now that you can have. If you make wait until done true, it will do this, and whilst it's doing this, you can do nothing else with it. But if you make wait till done false, whilst it's doing this, you could be data logging. So that's where you can put sort of variables in here. These tend to be, tends to be the drone name. This is the variable you're trying to control, speed or distance. This is the value. I think if you don't do it on, give it anything at all, it goes into some defaults. The defaults are, there's a user manual with this, which I'll send you. So the default values are in the user manual. So if, for instance, say we want, while the drone is hovering, we want to move the drone forward for 5 seconds. We could put move forward R5. So that's a simple command without some sort of more stuff down here. And then it's controlling the time it moves forward for. Now it'll have a certain speed, a default speed at which it moves, which again is in the manual. So there's a bit of like understanding about your drone here and how they're quite simple commands, but there's a little bit of weirdness inside here. You can do different things. You need to know how they work. So for instance, if we did move up are 5, speed 3, then this will move the drone up for 5 seconds at a speed of 3 meters per second. So you've got these like slightly strange almost degrees of freedom in here. And if you want to do distance, you have to put distance in there. But it's back to front on this, and distance and then the number. Whereas this one is, like it's a number and then the type of movement you want to make, and then 3. So you'd have to look quite carefully at the syntax associated with move up and try different things. And if the syntax goes wrong and you've got this code here, when the syntax goes wrong, this will crash, but then it'll go into this part here and it'll land. So that would be my first thing to do, really. Play about with, say, just move up with different variables in here. You can have distance, you can have speed, you can have time, you can have all sorts in here, and see how they work and which ones you like in terms of using them to control the drone. So I'll try and show you now some of those running with the drone. And of course with these you've got move back, move up, move down, move left, move right. So you've got quite a few, and you can also do coordinates movement as well. So you could move it to this thing here. Now one of the things Z is down is positive on the drone, and so if you wanted to go up you've got to put a negative number in there. So it's like, so 002 would move it up 2 meters. So there's a negative sign in there. Otherwise, if you put the wrong sign in, it'll just look like it's landing and crash into the floor. So that's probably the next one is rotating the drone, but we'll leave that for the moment. We'll now try and look at some of these commands here and how I could use them within the MATLAB environment. So here's the first one. It's move up the drone R. It's a distance of 1 meter. And that's not negative here, but it's 1 meter. It's put move up, it's 1 meter. And so there's a simple piece of code, and we can now say watch the drone doing this maneuver.
Right, so here's our second program now. So I've put a pause here to give me time when I press the run button to activate the webcam that's taking a picture of the drone flying. So pause can stop the program for 3 seconds in this point here. So as R as the rise, takes off the drone, and it's going to move forward a distance of 1 meter. Then it's going to go up 0.5 meter. Then it's going to move to the right 1 meter. Then it's going to stop for 2 seconds. It's going to move left 1 meter, so back to where it was here, and it's going to move back then 1 meter. So it should really take off and land at the same point. So here's the code here. I've got this extra bit in there as well, but this is the main code we're looking for. It's just using move forward, move up, move left, right, move left, move back, sort of typical ones, and we're using it to control distance. So we go onto the MATLAB button here and we press run, and then I'll have to immediately go onto the webcam. So here we go, press run, and here we go. So let's watch it now. And it's taken off, it takes off, and it stabilises. It's going forward, and it's done, forward towards it, and that's when it stops. So it goes up a bit, and it's going to go to the left. And it's going to wait for 2 seconds. It comes back. So it's going to go down. It's going back after the second, and it's landed. Not quite landed in the same place, notice, as it took off. So you can see it's not 100% accurate, which could be one little problem with it. But then when it's run the program. So if we run it again, just to see where it ends up this time, shall we? So this is, again, so you can see it's not totally repeatable. So click off, and you pull the meter. And you go up now. Next you go to the left. Stop. Next you go to the right. If you go down, you just go back. You go back now to where it started from. Probably land. You see it's losing about half a metre, or maybe less, 30 centimetres, something 20 centimetres per time it flies. But that gives you an idea now of how we could simply control the drone in MATLAB. If I was to make a mistake now, let's say we put in a semicolon in here now, so it'll go through these parts here, it'll get to pause. Well, let's not put it there, let's put a comma there, let's put a semicolon in here. So this is where you could easily make an error now. You could put, say, a full stop instead of a comma. So it's now going to get to this point here. When it gets to this point here, if you didn't have this bit of code, it would just stay there. But with this bit of code now, it will land from this, when it gets into this error condition here, it will land. So let's just watch that going as well. And then, oh no, this one doesn't like it. It spotted it. It's spotted, so it's told us get lost, it won't run. Let's put a comma back in there. Let's put A in there. See if that'll run. Yeah, so it's taken off. Here we go. Let it move forward. Let's move up. And move to the left. And if it comes back to the right, it won't like it. And come back to the right. Right. The landing bit, so it lands straight away. And if it lands straight, it will hit that area. So the code that we had, it moved left, then when it hit this code here, which is the move back, didn't like it, so then it landed automatically. So that's the little safety net that you've got inside that code. And with this now, you should be able to make your drone move in any sort of way that you want, really, using quite simple commands.